Data is absolutely everywhere. I mean, it powers every app you use, every decision a company makes, really every report that lands on your desk.
It really does.
But here's the crucial question. If the foundation, the data itself is bad or inconsistent or even malicious, how trustworthy are any of the results you get from it?
That's the core issue, isn't it?
We're not just talking about simple typos here. Today, we are diving deep into the indispensable world of data validation. We're using principles often outlined in foundational computing courses, like BTEC Level 3.
Good foundational stuff.
Yeah, and we're finding the shortcuts, the key ideas to understand these checks and balances that, honestly, keep the digital world from falling apart sometimes.
It feels like that occasionally.
Our mission today is really to give you the essential toolkit for understanding how systems maintain their integrity, specifically how you select, apply, and then interpret the validation techniques that make sure every piece of input is actually reliable.
Right. And maybe before we jump into the why, we should define the term clearly. Data validation, at its heart, is that proactive process. It's about ensuring the information someone enters into a system, could be a web form, a spreadsheet, a database, whatever is correct, relevant, and consistent.
Okay.
Think of it like the automatic bouncer at a digital nightclub. It checks every piece of data's ID before it gets in.
I like that analogy.
Yeah, if you skip this step, you're basically just inviting digital chaos right through the front door.
Okay, let's unpack that a bit. I mean, if a user is just typing in their name and maybe their age, why do we need this intense defensive mechanism? What are the biggest payoffs, the really crucial ones for, say, the developer or the organization that sets up these validation rules?
Oh, the payoffs go way beyond just catching minor typos.
Yeah.
They're really about maintaining reliability across the entire system. We can probably break it down into 5 critical benefits.
Okay.
Starting with the most fundamental one, data integrity. Simple as that. If your data is validated, you know it's accurate, reliable, and consistent, which means your analysis, your decisions based on that data, they're going to be sound.
Right, the classic garbage in, garbage out problem.
Exactly. Validation is the gate that stops the garbage from getting in the first place.
So, okay, if the integrity is protected, then the next logical benefit has to be about dealing with errors earlier, right? Catching them quickly.
Precisely. That's the second big one, error prevention. It is just exponentially cheaper and easier to catch a mistake right when the user makes it. You give them an immediate prompt.
Instead of finding it later.
Way later.
Yeah.
Imagine dealing with a corrupted database table or a miscalculated quarterly report 6 months down the line. It's just a nightmare. It's the difference between, say, catching a misspelled street address on a sign-up form right away versus having thousands of packages that you can't deliver later on.
Makes sense. Much easier up front.
Much. Then third, and this one is often overlooked, I think, is a vastly improved user experience. Well, good validation provides constructive, immediate feedback. If I type my phone number wrong, a good system tells me right then what I did wrong and maybe how to fix it.
Instead of just a vague error message.
Exactly. It prevents that user frustration.
Yeah.
It guides the user toward putting in the data correctly, which makes the system feel helpful, intuitive, not like it's just punishing you for a small mistake.
Okay. Integrity, error prevention, user experience. And then there's the technical stability of the whole system itself, I imagine.
You got it. System stability. That's number 4. Unexpected data, like a massive negative number where you expect a quantity, or weird symbols where only letters should be, that stuff can actually cause system crashes.
Seriously?
Oh, yeah. Validation ensures the data structure remains predictable. It helps prevent those fatal errors that could, take down the whole operation.
And you mentioned security before. That's where this seems to shift from just good housekeeping to like a serious defense mechanism. This is where it gets really interesting for me. How does something as basic as checking if an age is a number protect me from, say, a hacker?
Right. That's the 5th and arguably the most critical point today. Security. Validation is a key frontline defense against malicious data entry. Think about common attacks like SQL injection or cross-site scripting, often called XSS.
Okay.
What an attacker is trying to do there is sneak executable code, basically, a command into a field that's only designed for simple information, like a username field or a comment box.
Right. They're trying to trick the system into running their code.
Precisely.
Yeah.
So if the system expects, let's say, a user ID to be just a simple integer, a number, but the validation fails to check that data type properly.
Uh-oh.
Yeah, the attacker could input a command string, something dangerous like drop table users, instead of just a number like 1223. And if that malicious string gets past the validation and actually hits the database, the system might just execute that command. And poof, you could potentially wipe out huge amounts of critical data.
Wow. Okay, so failing a simple check, is this input a number or is it text or maybe code? That failure basically opens the door for a hacker to hijack the system through its own database commands. Data validation suddenly feels like the main lock on the front door.
That's absolutely right. It keeps the system honest, fundamentally. It prevents user input from becoming an attack vector.
Okay, so if that's the critical why, I mean, the stakes are clearly massive. Let's shift to the how. We're moving from the importance to the actual toolbox. Our sources lay out 4 essential techniques. Let's start with the 2 most foundational checks.
Sounds good. The first one is absolutely fundamental. Data type validation. This is the non-negotiable step. It ensures the input actually matches the format the computer needs to process it correctly.
So, like, is it a number? Is it text? Is it a date?
Exactly. If the system is expecting an integer, a whole number, for age or quantity or something, it must reject input that's a string of letters, or maybe a number with a decimal point if it's not expecting one.
And this can be tricky, right? Because sometimes things look like numbers to us, but aren't really numbers to the system.
Absolutely. That's a key point. The computer doesn't care if the text 51 looks like a number to a human. It cares if the input is stored as the numeric variable 51 or the text string 51.
Ah, the internal representation.
Precisely. If a field expects, say, a currency value for calculations and someone types in the words $5, that has to trigger a data type error. The system can't do math on text. It's all about making sure the data is in a machine-readable, processable format.
Okay, so once the computer knows it's dealing with the right type of data, say it's definitely a number, the next logical question seems to be, is that number even possible or realistic in the real world?
Exactly. And that's where the second fundamental check comes in, range validation.
The sanity check.
Perfect way to put it. It's the sanity check. It ensures the value falls within a predefined, realistic set of boundaries, a required magnitude. Think about test scores. They usually have to be between 0 and 100, right?
Right, you can't get 110% on most tests.
Or negative 10%. Similarly, our systems need to enforce realistic boundaries for things like age. We're generally not building databases for immortals or babies that haven't been born yet. So checking that the age isn't negative and maybe not over, say, 150 years old. That's a very standard range validation.
Okay, so just to recap quickly, data type asks, is this the correct kind of value, like number versus text? And range check asks, is this value believable? Is it within the accepted limit?
Exactly. Range uses magnitude, how big or small the number is, as its core criterion.
Got it. But not all data fits neatly into simple numeric types or ranges, does it? What about things that have to follow a really specific internal pattern, like, say, an email address or maybe a product code? We're moving beyond just magnitude now, aren't we? Into more customized formatting.
Yes, absolutely. And that brings us nicely to the third technique, constraint validation.
Okay, constraint.
This is where the validation starts to get more sophisticated, more tailored. Constraint validation goes beyond just checking the type or the simple magnitude or range. It enforces more complex, predefined rules about the data's format, its structure, or maybe required components. This is where you define the specific syntax the data must follow.
Syntax. Like grammar for data.
That's a great way to think about it.
Yeah.
It often involves using powerful tools, like regular expressions you might see them, called regex. These let the system check for very specific patterns.
Can you give an example?
Sure. An email address, for instance. It must contain exactly one @ symbol, right?
Right.
And it needs to have at least one dot, like .com or .org, after the @ symbol. That's a format constraint. Or maybe a company's product ID has a rule. It must be exactly 2 letters followed by exactly 4 numbers, like AZ1234.
Okay, so AZ123 would fail.
It would fail the constraint check, yes. Even though the types might be right, letters, numbers, the structure, the defined constraint, is wrong. It ensures the data has the correct internal architecture.
Okay, hang on. Let me try one. If I set a rule for a website password that says it must be a minimum of 8 characters long and maybe a maximum of 16 characters, is that range validation or constraint validation? Because it feels a bit like both. It has a minimum and maximum.
That's a fantastic question. It really helps clarify the difference. That would absolutely be constraint validation.
Oh, okay. What?
Because range validation is typically used for the numerical value of something like an age between 5 and 100. Constraint validation is used for things like the length of a string, like your password example, or its specific format, or the character set it must use. Maybe it needs 1 capital letter, 1 number.
I see. So constraint is about the rules of the structure, format, length. Range is about the numerical scale or value.
You've got it. Constraint defines the specific structure the input has to adhere to. Range checks if a numerical value falls within bounds.
That makes perfect sense now. Okay. Constraint is about structure. Range is about scale.
And that brings us to our final and probably the simplest check, Boolean validation.
Ah, the ultimate simplification, right? Just two choices.
Pretty much. It restricts the answer to only two possibilities, usually true or false, yes or no. It just eliminates ambiguity completely and ensures immediate clarity in the data.
Like on a form asking if a student needs bus transport.
Exactly. A school form asking that question only wants a yes or a no. It doesn't maybe next month or depends on the weather. Boolean validation forces that consistency by allowing only those specific valid choices.
Okay, so we've built this defensive wall now. Data type, range constraint, and Boolean checks. The system applies these checks, the user enters some data, the validation happens, it either passes or fails. But what does the system actually do next? That seems crucial.
It is crucial. That's defined by the post-check actions. These actions are the critical feedback loop. They determine the user experience, and they also ensure the system's ongoing stability based on the validation result.
Right.
We really have to think about two distinct scenarios here. What happens with invalid data and what happens with valid data.
Okay, let's take invalid first. The user messes up. They put letters in the age field.
Right. The system can't just, crash or ignore it. Ideally, it should display a clear, informative error message. Often, it highlights the specific field that failed the validation. This approach is sometimes called soft validation.
Soft validation, meaning it warns you but doesn't stop you entirely.
Often, yes. It guides the user. It tells them what's wrong, prompts them to correct the input. Maybe it says, please enter a number for age. And it often keeps looping, asking them to try again until the data finally meets the criteria.
Okay, so soft validation gives a warning, lets the user fix it, keeps them on the same page generally. Is there like a hard validation then?
Absolutely. Hard validation is stricter. It actually prevents the user from submitting the data or maybe even moving to the next step until the error is fixed.
Ah, okay. When would you use that?
It's often used for more critical checks, things essential for security or basic function. For example, if a required field, like username, is left completely blank, or, crucially, if the system detects something that looks like malicious code being entered.
Like that SQL injection attempt we talked about.
Exactly. In those cases, you don't want soft validation. You want hard validation. The form submission is just halted completely until that critical error is resolved. The system has to make a decision. Do I just flag this error with a little red box and let them fix it when they're ready? That's soft. Or do I actually prevent them from clicking submit until they fix this specific problem? That's hard.
And that decision, soft versus hard, that really defines the whole interaction, doesn't it? I mean, does the system clear the whole form and make the poor user start all over? Or does it just nicely highlight the one field that's wrong? That's the difference between a user cursing your application versus praising how helpful it is.
Precisely. These post-check actions, whether they involve looping back to prompt for correction or accepting the data and saving it to the database, they are what transform these abstract validation rules into a functional, reliable, and hopefully user-friendly piece of software.
And if the data is correct, passes all the checks.
Then the post-check action is usually straightforward. The system accepts it, saves it, maybe adds it to the database, or uses it in the next step of the process. That act of saving the correct data is what maintains the overall data integrity we talked about at the start.
Okay, so wrapping this up, what does this all really mean for you, the listener? We've basically covered the entire validation lifecycle, haven't we?
I think so.
We talked about why it matters, security, data integrity, user experience, system stability. We went through the main checks, data type, range, constraint, and the simple Boolean. And we just covered the necessary follow-up steps, those post-check actions, including soft and hard validation approaches.
Yeah, and I think the key takeaway is that data validation is really more than just some technical requirement checkbox. It's truly the fundamental step you take towards building reliability and trustworthiness into any system you build or analyze.
Right.
It guarantees that the raw, messy input you often receive gets transformed into something usable, consistent, and secure. It turns potentially chaotic information into a valuable, processable asset.
Okay, so we've established the rules, these validation techniques that govern how data gets into the system cleanly. But here's maybe a final provocative thought for you to mull over. Once a validation check is done, the system basically gets back a simple true or false result, right? The data passed or it failed.
Yes, fundamentally.
So how does the system then decide when exactly to apply these checks, and maybe more importantly, what path to take next based on that true-false outcome?
The sources we looked at suggest that the critical knowledge area that comes right after understanding validation is getting to grips with control structures.
Ah, yes, the logic flow. Exactly. Control structures are like the architectural formwork, the directions that dictate the flow of the program. They tell the system how to use the results of these validation checks to manage its next steps, its overall behavior. Something to think about until our next deep dive.